Hello there, amazing people. I'm super excited to be here with you on today's video where we get to treat yet another past question. Now, on the screen right now, we have a question that says, identify which of the following pairs of substances will react. We have carbon and copper oxide. Will they react or not? Well, let's find out. We also have iron and zinc nitrate. Will they react or not? Well, let us find out. We have iron plus magnesium oxide. Will they react or not? And then we have magnesium plus copper 2 sulfate. Let's find out which of the following pairs of substances will react. Now, in order to know whether a pair of substances will react, you need to know if there will be a displacement. What is a displacement? A displacement simply means if a compound or if an element that is standing alone will displace another element that is in a compound. So here is what we mean. For this first example over here, we have the element that is standing alone, carbon. And for these two pairs of substances to react, it means carbon must be able to displace the one that is in a compound, which is copper. So if carbon is able to displace copper, it means the two of them will react. So how do we know if carbon will be able to displace copper? We are going to check our reactivity series. So the element that is standing alone is carbon, and the one that is in a compound is copper. Between carbon and copper, which one is stronger? Let's check our reactivity series. Carbon, the position of carbon is over here, as you can see, and the position of copper is way below carbon. So it means carbon is stronger than copper. So that means carbon will be able to displace copper in a chemical reaction. So this reaction will actually take place. They will react because carbon will displace copper from this compound. I hope you're following. And then we have the second example, iron and zinc nitrate. So let's get our information available. The element that is standing alone is iron. As you can see over here, iron stands alone. And the element that is standing in a compound is zinc. Zinc is in a compound. So now we need to find out which one is stronger and which one is weaker between iron and zinc. So checking our reactivity series, you can see over here that iron is right below zinc. Iron is here and zinc is over here. So that means zinc is stronger than iron. So if iron comes over here to meet zinc, it means that it will not be able to displace zinc from its compound. So therefore, that means this chemical reaction will not react, or the reaction will not take place. I trust you're getting value from listening to me here. Now we have the third reaction, which is iron plus magnesium oxide. So we have iron standing alone, and the other element that is in a compound is magnesium. So let's find out which one is stronger between the two of them. So between the two of them on the reactivity series, we can see the position of iron to be over here. That's the position of iron. We can see the position of magnesium to be over here. So that means magnesium is stronger. Magnesium is stronger. And in this case, magnesium is the one that is in a compound. So that means when iron comes, it will not be able to displace magnesium from its compound. So therefore, this reaction will not take place because the stronger metal is the one that is in the compound. And then we have the final one, which is magnesium and copper 2 sulfate. So we have magnesium Mg and we also have copper Cu. So let's check out our reactivity series to see which one is stronger, magnesium and copper. Magnesium is over here, and then we have copper to be way below magnesium. So magnesium is stronger, so that means it will be able to displace copper from its compound. So when magnesium comes over here, copper would have to leave. So this reaction will actually take place. I trust you're following and you're getting value for your time. So the second aspect of this question asks us to do something interesting. It says write balanced symbol equations, including state symbols for the pairs that will react. We already know the pairs that will react. The first pair and the last pairs will react. So we have the first pair, which is carbon and copper 2 oxide. So we have carbon. Let's write it out. Carbon plus copper 2 oxide. So the symbol for carbon is C. Carbon exists in the solid state of matter, plus copper 2 oxide has the formula Cu. This also exists in the solid state of matter. Now, how will the reaction take place? We know that carbon is stronger, so carbon comes over here to knock off copper. So that means copper will have to leave. Therefore, the result of the equation means copper will stand alone as a solid plus carbon oxide. This is going to be in the gaseous state of matter. Carbon dioxide, CO2. So let's balance this chemical equation. We have carbon on the left hand side and we have carbon on the right hand side. One atom of carbon on both sides. So carbon is balanced. How about for copper? We have copper, one atom of copper on the left, one atom of copper on the right. So copper is also balanced. But for oxygen, we have one on the left and two on the right. So to balance oxygen, we'll put a coefficient of 2 over here. So therefore, oxygen is now balanced. So therefore, if oxygen is now balanced, we have also changed the number of atoms of copper here to be 2 on the left hand side. So we'll have to include another 2 here to make the full equation balanced. So let me rewrite that out. Solid carbon reacts with copper 2 oxide to produce solid copper plus carbon dioxide gas. This is the balanced equation for the first pair that will react. Let's check out the last pair and see what we have. The last pair says magnesium plus copper 2 sulfate. So we have magnesium and copper 2 sulfates. Magnesium and copper 2 sulfate. Magnesium has the symbol Mg, solid, and copper 2 sulfate, CuSO4. That is the formula for copper 2 sulfate. This is in the aqueous solution. So what's going to happen over here? Magnesium is going to come over here and knock off copper, making copper to stand alone. So we're going to have the product, which will be copper standing alone as a solid plus magnesium sulfate, MgSO4. So let's write out the full equation. We have Mg solid plus CuSO4. This is aqueous, giving us Cu, copper, which is solid, plus MgSO4. This is in the aqueous state of matter. I hope you got value for this. This equation is actually balanced from start to finish. One atom of magnesium on both sides, one atom of copper on both sides, one atom of sulfur on both sides, and 4 atoms of oxygen on both sides. Like, share, subscribe for more content like this as I prepare more to be uploaded to you. Thank you for staying with me till the end of this video. I will see you in the next one.